Nathan Hamill.
Thanks. I only expected 3 people to be up this morning, so thanks for coming out or not going out and drinking last night or being stuck here like I am because my flight was canceled too. This talk is about attacking APIs and application extensions. It's kind of early in the morning, so there's going to be some things in the slides that I'll probably take out later before the distribution to wider media. What this talk is about from a perspective of APIs is the APIs that you would create to connect and add functionality to your application, not APIs that are inside of programming languages that you might need to hook to for functionality. So I just wanted to clear that up a little bit. That was a lot nicer than the one I had in here, which was a little, maybe I'll show it later. So I am Nathan Hamill. I am a principal consultant for FishNet Security on the Application Security Group. I'm also an associate professor at UAT, and I founded Hexagon Security. And we don't really do much at Hexagon Security except go to conferences and hang out and talk, and every now and then we'll release something. So the net, from the early days of the net, we've all seen diagrams like this, these interconnected computers, but from a network level. And if one node on the net goes down, typically it doesn't affect something on the other side of the net from that perspective. And this architecture has been in place for a very long time. And it's really been figured out. So we've kind of got that whole deal figured out, and there's lots of redundancy and everything else. So typically it's pretty good. But lately, what's been happening is there's been an increasing amount of connections at the application level. And this becomes very interesting because of the attack surface. So we haven't quite gotten this whole application level thing figured out. And that's where a majority of the vulnerabilities are right now. And for some reason, all this interconnected functionality isn't really being properly validated. So even if you're doing something as simple as piping in an RSS feed into your application, how it's rendered on the page can be very problematic. It was not too long ago where the New York Times had like this feed reader where it would pull in a bunch of feeds. And there was an article on HTML injection, and it kind of encoded the characters. Well, when the feed went out and grabbed that feed, it actually performed HTML injection on the New York Times site, which is like very bad. So even though one site was doing it right, when that content got piped into another site, it was actually done incorrectly. And these are the kinds of things that that as developers they should be thinking about, and as attackers we should be thinking about as well, because when we're testing these things, we shouldn't make assumptions that everything has been done properly or that people have thought of even the most simple rudimentary things. And during this talk, I'm going to talk about specific examples of violating API structure and some, examples of that. There's really not a lot of, ODay dropping things in this talk, but if you test web applications or you develop web applications, hopefully it's pretty useful. So this connecting at the application layer, we have this mesh of content versus, traffic. So like I mentioned, RSS feeds. It also increases your attack surface. And content delivery goes far beyond, a user, functionality on your site. So if they were uploading pictures or sending messages, that's content. But also advertisements are content too. And there's been an increase of that lately as well, where people are buying ads, malicious ads on popular websites, and if not delivering attacks, they're definitely delivering things that aren't very nice. Pop-up windows that say, you need to go here and download this because your computer's about to die in 10 minutes. As well as less validation with higher trust. So when a developer decides to write something that pulls content in from an external location, it's seen as being at a higher trust level than if a user makes that decision. So we all know that developers make mistakes too. So there's a lot of assumptions being made about the content that gets delivered on a site. Whether it's hooked in through an API or pulled in through a feed, these assumptions will actually kill you in the end if not, taken seriously. So kind of this simple diagram of an API, it provides a content layer and delivery method for services and data on the back end. So it's this uniformed interface where you make calls and you hopefully get what you want. The reason there's so many vulnerabilities at the API level is because they're not thought of as being part of the application. So when you're having an engagement, or whether you're doing third-party validation, a lot of these times these things are not scoped into the assessment work, or they're not really thought of, and that can be a problem. And I think it's because a lot of times these aren't thought of being consumed by users; they're consumed by other applications. So there's a lot of assumptions there. And lately, since the popularity of extending these applications, you may have a legacy application that now needs to be extended, or functionality that existed in that legacy application that now needs to be consumed by a third party. And where we started seeing that was mobile. So in the early days of mobile web browsers, you had this, this really small screen and this really horrid, atrocious web browser that basically was only one step up from Lynx. And well, actually, Lynx actually had more functionality than that. So there had to be these separate interfaces created for them. So if you wanted to do online banking, you'd go to a different, URL that had different functionality for your mobile device versus, just visiting the web page with a web browser. So that's where we started to see some of this. And, now we have APIs for clients of varying girth. So these fat client applications are now using HTTP as a transport mechanism to send data back and forth and provide this functionality. So when you bolt on an API to an application, there's a lot of thought that needs to go into how it integrates, mainly because you can fix things in one area and they're still vulnerable in another if you're creating these multiple paths to the same functionality. APIs have the same problems as traditional applications. So from authentication, authorization, session management, accountability. Accountability is a big one because a lot of times API calls don't get logged. So if they don't get logged, when they're being abused, you have no idea they're being abused at all. Authentication and authorization are kind of interesting because when that gets tied into the application, when they're aware of each other's session data, that can be an interesting area for vulnerabilities as well, how that data gets passed back and forth, and I have a couple examples of that later on. And these APIs are often not fleshed out at implementation time, so where you see this more often is they have more or less dev code in production. So they're still figuring things out, but they pushed it out because of some time frame basis. And that goes back to lack of proper testing too before it makes it into production. So for API services, there's basically two types of APIs when we're talking about from an application level perspective. You have consumption APIs, which allow something to connect to your application and consume services. So say you had a currency conversion service that you were offering. This would be defined as a consumption service. So you can connect, you can send the appropriate data, and you get the appropriate response. So I now get my currency converted. Integration APIs are what really becomes interesting for an attacker because you're taking external content with a call and placing it in the direct path of a user, which is often what you want to do as an attacker if you are exploiting something like cross-site scripting or cross-site request forgery. Because when you put content in the path of a user, there's a couple of knowns at that point. As an attacker, you would know that the user is running into your content on a specific site. And if it's integrated after the user authenticated, now you have an authenticated user who's running into malicious content, which is pretty much win for an attacker. And of course, there's the one API to rule them all. So there's nothing saying that your API can't provide both consumption and integration. Probably one of the most simple to understand is Twitter, right? Twitter is a very simple web application. However, it allows you to use third-party applications to, get your messages, and it allows you to then integrate content back in. So you're sending messages that then end up being integrated on their site. As you might imagine, APIs make great targets if you're an attacker. basically because they increase your attack surface. And that could be over doubling the amount of inputs you have. You may extend the application so far that for every input to the application, there's an associated API call for it, and then beyond that, you may have functions that aren't available to regular users that are now available through the API. So maybe a regular user can perform all these functions. Let's say Twitter, for example. Maybe a user can add content and get their content, but if you have API calls, maybe you can see the rate that the person posts, or maybe you can get trends that weren't available through the regular interface. So now you're creating more inputs that then have to be validated and checked. The typical depth of an API is more than a standard user. So the user may have a set of functionality that they have access to, where the API is far beyond that. And if you think about it, a user to access functionality may have to go through like 4, 5, 6 different menus to get to what they're trying to do. Like say for instance they were going to send a message to somebody. They would have to log into the application. They would have to go to the messages menu. They would have to hit compose. They would have to add their data, and then they would have to hit send. Well, add a data, add a recipient, and then hit send. Whereas an API call, it might be one call. So now you have all of this functionality in one specific location, very easy to consume. And as you might imagine, if you have more expanded functionality, you also have elevated privileges. So you need to have elevated privileges to consume these extra sources. And what comes along with elevated privileges is higher trust levels. So now your API is operating at a higher... I love that picture too, by the way. I mean, who wouldn't want the king hitting on them, right? So you have higher trust levels. So as going back to people making assumptions about content that are coming into the application, those assumptions are assumptions at a higher trust level because it's seen that applications and other developers are consuming resources and not users. However, they're not thinking about the things that are leaked to a user through just standard calls. So there is some good news to all this. And it's that people are using standard protocols and data formats when they're creating their APIs. So there's not a lot of reinventing the wheel from that perspective, which is good because some of these things we've kind of already fleshed out. Like data formats is probably not, we probably don't need to use some weird binary format that we created ourselves when connecting to these things. So there's less vulnerabilities from a reinvention perspective, so you don't have to worry about things at that much lower level. And they're also readable and understandable. So if you don't know what JSON looks like, it's very easy to find out what that is from a couple of searches. And it also means your standard common tools can be used to analyze API calls. So you can use your standard Wireshark, Burp, WebScarab, whatever you want to analyze these. So what I kind of came up with for API testing was a simple little method to go through and identify the presence, the purpose of the API, the structure of the calls, and then of course violate those structures and then evaluate the results. So most of the rest of the presentation deals with either identifying the purpose and structure and of course the fun part, which is violating that purpose and structure. You basically have two methods for identifying APIs, as you might imagine. There's zero knowledge and documented. So zero knowledge would be for kind of internal APIs, and documented is pretty self-explanatory. And since I didn't want to put anything else on this slide, I just figured I'd add that in there. Ninjas are everywhere. And since APIs are meant for consumption, most often there are documentation laying out there somewhere, even if it's not meant for you to see. Because we all know that people only put appropriate things on websites, right? Like nobody would ever put documents to default passwords for ATMs or anything like that on their corporate website. So you might be surprised when going through and doing testing, you might run into documentation for APIs that aren't published publicly. And that can be a win for everybody. Well, if you're the testing team, it'd be a win for you. So you can search for applications using search engines, it's pretty obvious. So if you didn't know Twitter had an API from just Googling for Twitter API, you might notice that, hey, well, I use a Twitter application on my phone or I use a Twitter application on my desktop. So it's probably